So reviewing for the Chapter 8 quiz number 2, right? Some theoretical probability to start things off. This would be independent events, right? Each coin flip is going to be its own individual probability, right? So each coin flip has a 1 in 2 chance of happening. Looks like we're flipping 5 coins. Right, so we're going to multiply 1/2 times itself 5 times. So that'd be the same as 1/2 to the 5th power. Be 1/32. If you wanted to make that into a percentage, you could do that on the calculator. 1 divided by 32, that would be a 3.125% chance. Right, so 3.125%. I'm not going to work through all of those percentages on this review, but I just wanted to show you we divide that fraction, multiply it by 100. So some marble selection here in problem 2. Looks like we have 15 marbles in the bag. No replacement, so the marbles are not going back in the bag. So what is the probability that you select a red marble first, right? Red and then blue, right? So a red marble would be a 2 in 15 chance. And then follow that up with a blue. There's 3 blues, but there would only be 14 marbles left in the bag then. Okay, so that would be a 6 out of 15 times 14, 210 chance. So then on number 2, or part B, I guess, 2 yellows. There's 6 yellows the first time. And then there would be 5 yellows the second time. Right, so you would have that. You'd have a 30 in 210 chance. 5 times 6 is 30. 15 times 14 is still 210. And part C, white marble. Looks like 4 white, 15. And then a red, 2 red, 14. Give me an 8 in 210 chance. In part D, we're picking 3 marbles now, right? So a red, 2 out of 15. And then a blue, be 3 out of 14. And then the third marble is yellow. That would be 6 out of 13. So 2 times 3 times 6 would be 36. And then to get my new denominator, I need to multiply on that 13, 27,000, or 2,730, 2,730. Not 27,000, that'd be a little ridiculous. So 36 in a 2,730 chance. Problem 3, people in a room randomly selecting with no replacement. So we're going to pick 4 people. So what is the probability? We draw 4 men in a row. First one would be 8 out of 14, 7 out of 13, and then 6 out of 12, and then 5 out of 11. Right, because we started off with 8 men and then decreases from there. So 8 times 7 times 6 times 5. 1680. Then my denominator would be 14 times 13 times 12 times 11. 24,024. Right, and just checking that out, 1680 divided by 24,024. Right, that's about a 7% chance of happening. For part B, they want to know if you draw 2 women and then 2 men, so 6 out of 14, and 5 out of 13, 8 out of 12, and then 7 out of 11. And if you multiply your numerators and your denominators, you would end up with the same thing, actually, as part A. For part C, 8 and 14 chance that we draw 1 man, and then 6 out of 13, 5 out of 12, and then 4 out of 11. So my denominator is still going to be the same. My numerator is going to be a little different than what we've had before. 960. And then, of course, you could do any simplifying with those fractions, turn them into percents, whatever it is you need to do. Rolling dice. This is where we need that table. So we write our possible outcomes of each die separately. And then since we're doing all sums here, right, they're all sums in these problems, we're just going to sum the sides. So a 1 and a 1, a 1 and a 2, and so on. Second row will be a 2 and a 1, a 2 and a 2, a 2 and a 3. Last row. So probably need to box some things out here to make this practical in seeing our outcomes. So probability we get a 5 or a 6. I can mark those out there in blue. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 and 36, a 1 in 4 chance. More than 7. Got a line here. Right, I'm not including the 7 because I need more than 7. So it would be this part. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 in 36 chance. And then sum is less than 4. That would be over here. Right, those 3 outcomes out of 36 because it's a 6 by 6 grid. Some combinations here to end out our lesson, right? 52 cards in the deck, choosing 5, right? 52 making combinations of 5. I'm just going to plug that in 52 first, hit the math button, over to probability, down to number 3. Right? Always enter that first value before you go to the NCR in the calculator. $2,598,960 possible outcomes. And then Laker Lotto, right? 1 winning combination, and then 54 total numbers. We're looking for combinations of 5. Right, so 54 NCR 5 goes up to 3,162,510. So if I were to divide that out, 1 over 3,162,510 510, right? I get this error on the screen. That means that I move that decimal 7 places to the left. So that would be 0 point and then 6 zeros. 316. To turn that into then a percentage, right? This would be our percentage chance of winning. So this tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. We have 300 thousandths of a percent chance of winning, which means pretty much a 0% chance of winning. So that is a quick review of the second half of Chapter 8.